Good day, grade 7. Our topic is about square roots and irrational numbers. Here is our learning targets. Define and describe irrational numbers. Identify principal square roots and tell whether they are rational or irrational. Determine between what two integers the square root of a number is. Essential question. So at the end of our discussion, we are going to answer this one. How useful are rational and irrational in real life? Have a simple recall about rational numbers. Rational numbers can be written in the form a over b, where b should not be equal to 0, or simply, it is a quotient or a ratio of two integers. For example, we have 1/2. It is also a terminating decimals and repeating non-terminating decimals like 0.5 and we have this one, 0.23. Square roots. The square root of a number is a value that, when multiplied by itself, gives the number. And the symbols for square rooting is, we have this radical symbol. Let's have this example. What is a square root of 36? Now, what number is multiplied by itself is equal to 36? Okay, it is 6. Since 6 times 6, we get 36. -6 also. Since -6 times -6 is equal to 36. But we will only be taking its positive square roots. Therefore, the square root of 36 is equal to 6, or we call this one as its principal root. We also call this as a positive square root. When there is no positive negative or negative in front of the radical, the principal root is usually assumed. Let's have these examples. The negative square root of 16 is -4. The positive negative square root of 100, we get positive -10. And the square root of 49, we get 7. Take note, class, that the square root of perfect square numbers are rational. They can be written as a quotient or ratio of two integers. Irrational numbers. Irrational numbers is a number that cannot be written as a quotient of two integers. It is a non-terminating decimal and a decimal that does not repeat. Examples: the value of pi, the Euler's number, the value of the square root of 3. So as you can see, it is a non-terminating decimals and the decimal does not repeat. Let's also take note, class, that the square roots of numbers that are not perfect squares are irrational. They cannot be written in the form a over b. Between what two integers the square root of a number is? So we're going to find out where does an irrational numbers lie. For example, the square root of 83. Let's figure out what the two consecutive integers square root of 83 is between. So the closest perfect square numbers to 83 is 81 and 100. Since the square root of 81 is equal to 9 and the square root of 100 is equal to 10, so the two consecutive integers are 9 and 10. Thus, the square root of 83 lies between 9 and 10. So let's summarize what we have discussed. At last, these are the differences between the rational numbers and irrational numbers. So let's go back to our essential question. So how useful are rational and irrational numbers in real life? Rational and irrational numbers in real life. So for rational numbers are used all the time, from buying and selling products using money and terminating decimals to cooking with fractions. People use rational numbers just about every day. One of the most practical applications of irrational numbers also is finding the circumference of a circle. Okay, so that ends our discussion. I hope you have learned a lot.